So we'll basically understand how gradient descent actually works for one iteration. Then after that, we'll basically understand when does it stop, right? So since this is an iterative process, you can't expect this to keep on running continuously. So this basically is the function which gets one iteration. So points, your points is nothing but your data frame. Okay, so it's nothing but your it's nothing but your common data frame. Okay. So this is step gradient, and then you basically this is your initial values, p gradient, and so this is nothing but your initial values. You just use b gradient and m gradient. So this is nothing but your initial values. So next, basically, what you do is again these you're just trying to get the length of points. Now this is where the actual gradient calculation happens, right? So for I in so basically what is the idea is you're just looping over your entire data set. Okay, so for each data point, for each row, okay, for each row you basically calculate the value of b gradient and m gradient, then you add them up. Okay, then you basically collate it in you basically aggregate them in a particular in a particular variable, and finally you just after you have done looping over the entire data set, so that value will basically subtract it. Okay, basically subtract it from your original position, right? Your original point. Obviously, you don't directly subtract it. You sort of basically multiply it by the learning rate, then subtract it. So that is what is your next step. Right? I'll basically tell you what is your magnitude of your next step. In case you don't follow this, maybe when we're done with this particular function, I think things should be more helpful. So you're just looping over your entire data set. Now this is your x, right? So this is the x and this is the y, right? Now this is where you basically calculate your gradient. Gradient is nothing but your derivative, right? So gradient is nothing but your particular derivative. So your normal cost function, right? So your cost function normal is say y minus so this is what is the cost function, right? Mean squared error. You're just taking the mean of your squared error. And you need to calculate derivative. So how do you calculate derivatives? Nothing but you basically use your chain rule, right? So what is the idea? What is the idea of chain rule is nothing but so now your complex function, right? You just basically assume that this whole function is nothing but it's considered of a single variable. So in this case, you consider the whole thing as x. So basically, what happens now is you just consider the whole thing as x square, and it becomes 2 by n, 2 by n into 2 by n into derivative of this, right? Now, basically, what you need to do is you basically need to calculate 2 by n into derivative of x square is nothing but 2x, right? Now you basically need to calculate the derivative of this, right? Now, since you're basically trying to find out a partial derivative with respect to b, this one becomes 0, right? This one becomes 0. You're left with only -1. So this is what is a partial derivative of your y term with respect to b, right? Now, why do we need to take partial derivative and not complete derivative? Is basically since we have this thing of multiple variables. You what basically we are interested is we're just basically interested in finding out the best value of m and the best value of b. And since we are only interested in these two, we actually take derivative only with respect to these two things only. Okay. Next is derivative of dou y by dou b. Next is you take a derivative of basically y with respect to your m, right? You basically take the derivative of y with respect to your m. So what happens in that particular case? Again, it's the same 2 by n only, because again you assume this as x square. You assume this as x square and you just take 2 by n only. So in this particular case, what basically changes is this one is obviously 0. This one becomes 0. You're left with minus x, right? Because derivative of mx is nothing but minus x, right? So this is what is a partial derivative of your y with respect to b and with respect to m. So that's what we'll basically input it over there.